2020, but we will have some in spring, so watch out for that too. Uh, to give an intro, my name is Alicia Murphy. I'm the president of SF Hacks. You might see some of our officers in the Zoom room right now, but SF Hacks' main goal is to provide computer science events to the student body. We focus on hackathons. You might have seen our hackathons on campus when we were on campus. And this year we'll be having our first virtual hackathon in March of 2021. So we're all very excited for that, and I hope to see all of you there. Next, I'll give it off to Melissa.
Hi, I'm Melissa. I am the current president of ACM, which is an international organization that pretty much provides resources and is great for meeting people and professionals. When you join ACM, if you pay for the paid membership, you get access to a database and to newsletters and a bunch of great stuff. And we get speakers that come in and speak to us periodically. So we can always, like, if you're interested in something, contact us and we'll try and find a professional that can come and speak to you about it, or to us about it. Yeah, thank you.
Awesome. So today we're all here for AR/VR, hosted by Joyce Lee from Google. I'm going to hand it off to Joyce, but before I do, I'm going to quickly take a group photo of all of us in the Zoom right now. So if you guys want to turn on your camera, if you want, it's not mandatory at all. This photo will be on our social medias and our LinkedIn, all of that, just for memory. So I'll count down from 3. Ready? 1, 2, 3, cheese. Okay, there's one more page of people. So let me get the other page.
Is it a screenshot?
Again. Yeah, it's a screenshot. Oh, sorry, you guys. Okay, ready? 1, 2, 3, cheese. Perfect. Okay. Okay, I'm going to hand it off to Joyce, our wonderful presenter today, and I'll talk to you guys at the end of the workshop.
Hi, can you guys hear me okay?
Yep.
Yes. Yep.
All right, sweet. Yeah, we don't really get to use Zoom at Google, so I'll be maybe fumbling through it a little bit. But if you can't hear me or you can't see me, you can't see what I'm talking about, just let me know. So
before we start, can I add one thing, just really quickly? This is a statement for everyone in here. A lot of times we hold these workshops and people are afraid to ask questions and unmute themselves. I just want everyone to know that it's totally okay to interrupt me, interrupt Joyce, Melissa, anyone. This is just an environment for us to learn AR or whatever topic we're talking on during the day. So please unmute yourself if you have a question.
Yeah, definitely. I'm going to kind of assume, like, I'm going to assume something about what you guys already know. So if I skim over something that you'd like clarified, definitely just feel free to hop on and ask me to clarify. Cool. So hope you can all see my screen. And yeah, so I guess a little bit about myself. So my interest in computer graphics, so how I got into AR and VR is I actually started working on computer graphics when I was back in high school, which was kind of a really novel experience. I think I grew up in New York City, and I was in one of the first few computer programs within public schools there. And one thing that our CS teacher thought would be an interesting problem for people who were just starting out in programming was to teach you how to write a ray tracer. And so I found this really interesting because I liked linear algebra at the time. I liked math, and this was a very natural transition for me. And I found it really useful going into college and whatnot, because in college I found that they focus on libraries such as OpenGL, but they don't really they explain to you how to use it, but not a lot of the fundamentals underneath it. And so that's what got me into computer graphics in the first place. When I got out of college, it was kind of an interesting time for AR VR just because it was right around when everyone thought the industry was going to blow up. It was like the hot VC topic. There were 101 VR startups popping up every day. And it was just a really exciting time to be in the space. And what really intrigued me about it was that I thought that we were on the cusp of something like the next mobile revolution, or even taking a step back, something like the next desktop revolution. Like if you think about how desktop space came to be, like how these mouse and keyboard interactions we're used to doing all the time, those weren't fleshed out even just a few years ago. And so when I initially started working in VR and AR, it was very exploratory. And trying to figure out what people liked, what people disliked, and what people found intuitive, which turns out to be extremely important. And so the product that I first worked on when I joined Google was TiltBrush, and that it's a VR content creation tool. And as much as I enjoyed, I found creating very pretty things rewarding. I also found just using it to polish these very complex user interactions. If you think things like, Maya and Houdini that have so many keyboard controls for it, how do you distill it down to a much simpler set of user interfaces that you have available to you in VR? So that was I want to say four years back or so at this point. When the VR craze kind of died down a little bit, I decided to learn about something a little bit different. I've overheard some of the conversations before my talk about choosing between courses. And one course I didn't take when I was in college was machine learning. And so I decided to take a role at Tesla where I could apply my knowledge in graphics to their computer vision team and help with working on their autopilot system. And that was a great learning experience for me personally, because computer vision is almost the exact opposite. It's the inverse problem of computer graphics. And so I learned something about, just addressing that slightly different problem space, which re-engaged me back to come to Google back again, where I now work on a kind of R&D AR project with a machine learning component. So I am working in AR VR again, and very excited to share what I know about it. And I guess AR and VR. VR is still one of my favorite things, and I continue to watch the industry and hope it gets big again. And one thing that's been pushing VR development for the general community that I'm very excited about is is a game engine called Unity. So Unity is a company that it was a startup, it recently IPO'd, but their product is a cross-platform game engine. So you can write your code once in this game engine and then deploy it across Android, iOS, desktop, with minor modifications. But the goal is that you only have to create your game once and you can hit a much larger user base than what you could previously if you were only using something like Android Studio or only using Xcode. And so for those of you who have never been introduced to Unity before and maybe just downloaded and installed it for this workshop, I just wanted to cover a couple basic things that I'll be using during my tutorial. So the first thing I'll bring up is game objects. So game objects are pretty much what the name sounds like. They are objects that you can place in what we call a scene. So that's anything that's within your game. The next thing is scripts. So scripts are behaviors. They're things that they're code that you can attach to your game objects that control what they look like and how they move and things like that. And game state and whatnot is included in this. The third thing is prefabs. So prefabs are, you want to think of them as like a stored game object. So you'll see once we start working with game objects is that they can contain a lot of state. They can have scripts attached. They can have other components. And basically a prefab packages that all together for you in a very simple way so that you can reuse it throughout your game either dynamically or even just like setting up however many you want to before you start the game can be tedious if you don't have it kind of prefabbed. And then the last one is a hierarchy. So this is how Unity represents the scene graph. And for a brief description of the scene graph, it's a data structure that is the logical representation of everything in your game. And the way the reason why we call it a graph is it contains data as far as a parent-child relationship between objects in your scene and a transformation matrix between them. So you basically want to think about like if a scene graph of your hand, you have all your fingertips, that every one of your joints is one of those transformations. But if you move your hand, you only have to change, if you move your wrist, you only have to change one transform, and you can affect all the child objects. And so I think all game engines are represented like this just because it makes the math of calculating where objects are in the space actually kind of reasonable and practical. And with that, I want to show you how to set up your first AR app in Unity. So I'm going to move over to this Unity Hub, which I believe I asked you all to try to install prior to this. So Unity has many different versions, and each version has a slightly different set of libraries and packages it has available to it. And so I have, so Unity Hub allows for easy coordination of all of this. And so I'm going to create a new project using 2019.4.1. So this is their latest long-term support release, which just means their betas change rapidly, and the ones that aren't considered long-term support, their libraries are in flux as well. And so if you want to reliably have something that doesn't take routine maintenance to keep up to date, I would recommend picking a long-term support version. So I'm going to create a new project, call it SF Hacks Example. Then taking a moment to create everything. Let's see, why is it not opening? There we go. All right, so a brief tour of the editor. You see what I just mentioned here with the hierarchy. In your project here, you'll find basically all the assets that you have for your project. So that this includes things like your scripts and your prefabs and your scenes. So a game can have multiple scenes, but we're going to start with just a single one here. Your inspector gives you information about objects in your scene. And then once you start building and adding, trying to build and adding scripts, your console will be providing you all your debug information. And these things are reconfigurable. You can move your console around and all these tabs and add more tabs if you would like.
There's a question in the chat. There's a question in the chat, and someone asked if they should make a plain 3D project.
Yeah, just simple 3D is good.
Cool. We can continue.
So what I want to start with is to show you what Unity has done to make VR and AR development really easy. These are relatively recent changes. They started adding this ability, well, I guess only in 2018, but it stabilized only in 2019, which is why I'm showing you, which is why I recommended this version of Unity. So this is quite recent. And so the thing that they added that's been pretty huge is this AR Foundation package. And so this AR Foundation package, taking a step back, we're speaking mostly about mobile AR. And at this point, we have iPhones, which implement ARKit. And ARKit is built on the fact that iPhones come with a set of depth sensors on all their cameras, and they utilize that to create planes within, or to recognize planes within the world. Most Android phones do not come with this kind of hardware. And so what they do instead is they use the AR core library, which uses only machine learning on the video feed to identify the same planes. And because of this, they have a slightly different feature set and they have slightly different behaviors. But the worst part is that they have different APIs. So developer, prior to something like AR Foundation coming around, basically had to pick one and just omit the rest of, omit the rest of the market. With AR Foundation, you have a slightly restricted toolkit from both AR Core and ARKit, but most of the functionality that you'll need is available. It's only very specific use cases that will be not available from either toolkit. So basically, what we want to do in this package manager is very simple. You just want to install it. So along with AR Foundation, you also want to grab either AR Core if you're on Android, or ARKit if you're on iPhone, or both if you want to compile for either one of them. And then you should get this AR subsystems as well. That should come automatically when you install AR Foundation. All right, so once you have all 4 of these, you can exit out of the package manager and take a look at the build settings. And so it defaults to this PC, Mac, and Linux standalone, but we want either iOS or Android. So I am working on a Mac with an iPhone, so I'm going to select iOS. Actually, there's something I want to show you on the Android side, though. So I'm not going to switch to Android, but I'm going to show you the player settings. And if you bother digging through all of this, there's one thing I want to warn you away from, which is this XR setting. So it's AR. This is AR Core supported. You actually want to leave that unchecked if you're using AR Foundations. This is because you want to use the AR Foundations library instead of the native AR Core library. AR Foundations, where it's required for compute requirements, performance requirements, it becomes native code anyway. So it's not necessary to use AR Core, even if you're on Android. All right, so getting started with the scene, it defaults to providing you this main camera and a directional light. We actually don't want either of those. Instead, you'll see once you've installed the AR Foundation package, it will add this XR option to your menu. And so what we want is we are creating an AR session because we're creating an AR app, and we want to create this session origin. As far as AR goes, when you start when you start an AR app, the session origin is usually where you're standing. It utilizes this AR camera that has a tracked pose driver, and basically all this is saying is in this case, you're saying your device, your camera is the camera that you are operating over here. Track pose driver can also be attached to other game objects, such as if you had a VR device and you had controllers, your track pose driver could apply to those controllers as well. But in our case, we're starting with a camera that we are initializing in the origin of the world. Right. So what I want to do next is I want to create a plane that we can use to visualize where our AR app is seeing planes in the world. And so I want to go back into this XR menu and choose AR default plane. And so what you can see here is just a plane, and it provides this kind of like brownish material for us. Unfortunately, you see things like under this material, you can't actually change much. And the reason is because this is provided as one of the materials in the package. So we actually can't edit that. What we can do instead is we can go back into our assets and we can create our own material. And let's just call this plain debug material. You name that whatever you want. And so now you can see we can change things like color, whatever color you want to make it. I'm going to make mine this kind of light blue. You can also do alpha in case you want to be able to see through your debug plane. If you do alpha, you want to make sure the rendering mode is set to transparent. And then we can go back to our default plane and replace this material here. So now, whenever this plane is, whenever this object is created, we want to use this material. And I misspelled material.
In the
Apologies.
chat, someone asked, how do they get the AR default plane?
You right click in the hierarchy and go to XR, and then you see this AR default plane. Yeah, cool. So this AR default plane it's a prefab provided by the package, but we don't want the one that was provided by the package. We want the one with our new material. So what we can do is we can just drag this out of the hierarchy into our assets, and then this creates a prefab, which I mentioned earlier. And so this prefab, you'll notice, is configured with our customized material. And so this also turns blue to show that it's now a prefab. So we know it's saved. We can now remove it and go back into our session. What we want to add here now is you can add a component, and in this case, we want to add AR Plane Manager. And so this basically just allows our app to detect planes in the scene. So you can choose everything, nothing, horizontal, vertical. And I guess in my case, I want to detect only horizontal. I want to detect only horizontal planes because I want to put things on the ground. It's also asking for this plane prefab, which we can now provide to it. And basically what this manager does is if it detects a plane in this mode, then it will apply a plane to that surface. It'll display that object on the surface. All right. Well, I'll just leave that as everything. But depends on what you're looking for, right? If you're trying to apply like stickers to walls in your environment, then you want to choose vertical planes. If you're trying to put things on the ground, then you want to only choose the horizontal one. So now I'm going to take a moment and find an object that I want to place in the world. So just a very basic AR app object placement. And so I want to show you this site. Unfortunately, Google actually announced just today that they're turning this down, which is pretty unfortunate. But at least it'll be up in time for the time that your hackathon is happening. So I hope you'll make use of it.
Quick question about that. Is Poly, from what I remember, Poly was where all the tilt brush and blocks stuff went to. What is going to happen to all that? Is there not going to be like a community set of 3D things for tilt brush and blocks?
So that's a good question. I really hope there is, just because there is so much amazing,
so many great things.
What I hope happens is that we've provided the artists enough heads up so that they can download all of their stuff, and whenever another hosting site goes up for it, they'd be able to repost their work. What I will say is all Tiltbrush assets are, you can export them as Unity objects. And so you can export your, if you create something in Tiltbrush, it's very easy to export it to a file and then bring it back into a Unity game. And so the hope is artists will at least try to do that. Perhaps, you know, it'll be a little bit more difficult, it'll be more old school. You'll have to email someone a file to share it, but we'll see how that goes.
Thanks.
But yeah, you're absolutely correct. This hosts Tiltbrush files, this hosts block files, and we added, I guess, you know, a host of other things. But you're completely right. It's mostly a trove of Tiltbrush art. For this case, I'm going to recommend, because importing Tiltbrush assets is a little bit more difficult, I would recommend trying to import a blocks asset. You can basically pick any one that tickles your fancy. I am going to go into my stuff just because I don't want to, you know, take advantage of someone else's work. So these are a couple that I've built. I'm just going to download the original OBJ file. You can see there are a couple different file formats here, but OBJ is easiest to work with. And for those of you who aren't familiar, OBJ is it's almost a plain text file. You can inspect it if you want to, but pretty much anything that deals with 3D data will be able to read and use OBJ files. So what you want to do here, so I have downloaded my model. It's this one right here. And so because you want the material and the model to be associated, you want to just drag this entire folder into Unity. And then you'll get this little folder. And then if you click on the model, you'll see this little preview of your model over here. I don't know if I can make that bigger. There we go. You can see a little preview of the model you selected from Poly. So what you can do now is you can just drag it into your scene. And in your scene, it's going to look completely black. The reason for this is because there are no lights in your scene right now. So, you know, if you don't apply light to anything, there are no colors. Most of the colors we see in our world are reflected light back into our eyes. And when you build your application, the light source is actually provided by AR Foundation. So AR Foundation assesses the lighting condition of your environment and then attempts to apply that that lighting condition to all the objects, all the AR objects that you put into it. So there's a little problem with this. If you notice, most of these models, they have an arbitrary center. And let me move this a little bit so you can see more clearly. But you can see that my little reindeer over here is actually halfway under the ground. And so we want to, if we want to fix it, we can do this. You can create a game object. And this game object doesn't have anything in it. It doesn't need any behaviors, because all it's doing is providing this transform. So this is like the joint that I mentioned. It doesn't actually do anything. It's just providing an offset. And then you can drag your model under this game object. And then name it, I'm just going to name it capital model. But now I can go and I can apply transforms. So right now I have an X offset. I want to get rid of that. And let's say I want my reindeer to show up above the ground. And so I can move in. You can see how the values over here update with when I drag these arrows around. You can also type in the values. It's just whether you're trying to aim for a certain look or you want it to be precise, that's completely up to you. And what I want to do now is I want to save that back as a prefab. So I want to have this capital M model, which is my original poly model modified with this offset. And I can get rid of that. Now that I have the prefab saved. So now we have all the assets we need within Unity, except we need a script that controls the game state, if you will, that controls the state of the application to add our reindeer, or in my case, to add my reindeer to the environment. And so I'm going to go back to the assets and create a C# script, and I'm going to call it place on plane. Because all the script is going to do is it's going to, when a plane is detected in my scene, I want it to put my model wherever I tap it. So that's all this script is going to do. Double click it and it should open in your editor of choice. So Unity does have some pretty nice plugins that should install when you install Unity and help you autocomplete. Unfortunately, you can see there's something kind of wrong with my setup, and so there is no autocomplete on my machine. So you'll have to bear with me as I type things out. I do apologize. But it's pretty easy to get started with this, to start scripting using the AR Foundations kit. So you want to just import it. So it's Unity engine. It's under XR, and then you want to do AR Foundation. So you can just import that. This relies on the other library that you saw that imported automatically, which is AR Subsystems. Oops. Cool. So what are the variables that we need in order to do this? Well, so the way that we place something on a plane is what we call raycasting. So basically you touch a point on the screen and it takes where you touched on the screen and the direction of the camera and uses that to determine where on the plane you meant to place the object. And so in order to take advantage of this, with this class within the AR Foundations library, you just have to find the right name. So this is called AR Raycast Manager.
Someone has their hand up. It looks like Peter has their hand up. Did you have a question, Peter?
Yes, actually, does this also work with iPad OS?
Yes.
Okay then.
I would say Apple publishes which devices are ARKit compatible. I can't say all iPads are, but certainly like the latest generation, the ones that basically use Face ID and technologies like that, it's the same technology that they're using for ARKit. Yes, I would say I should confirm this, but I believe that certain iPads do support this as well.
As far as this script, is this a new script we're creating from scratch, or are we editing something that's part of the foundations or something?
So you want to, yes and no. So this is a new script. You want to go into your assets along with your models and the rest of your materials. And then if you right click on this, you can do create, and you want to just add C# script. And then you can name it whatever you want, hopefully something well named. And there's a little preview over here. And what I was editing was just double clicking on the script, which opens up their template for a script, which basically just populates the class name and then gives you these methods. And they have a Unity has if you go onto their developer page, they actually tell you what these functions mean. So Unity is built on top of C#. These are not standard functions within C#, but they are standard within the engine and called on all of these mono behaviors, which are basically what all the scripts are. And so start is when the object is created. You want to think of it as the constructor. And then update is called every frame. So every frame is when your screen refreshes. And so these are the ones they give you to start with. There are other functions that are applicable to all mono behaviors that are a little bit more specific if you have need of it, but these two are really all you need to get started. Is that, are there any more questions?
I don't think so at the moment.
Okay. Cool. Thanks for pausing me. Don't want anyone to get left behind on where to find these files. So the other thing we'll need here is we'll just need what we're trying to get, right, are these raycast hits. This is populated. This is used and populated by the AR Foundation library when we ask it to find them. And so what we want to do to this raycast manager is we want to do this, call this library Unity specific function called get component. And we want it to, it's parameterized with the type we want it to look for. And so basically what this does is these scripts, they're attached to game objects. And what get component does is it looks at all the components attached to this object and checks if there's one of this type. And if there is, then it returns that. So we want the raycast manager, and then hits, we just want, it's just a list. And yeah. I can type. So we just want a new list here. What we actually also want is we want to specify the object that we want to be placed when we tap the world. So this we can call it public, and this we'll just call it prefab. But if for whatever reason we don't want this to be just publicly accessible, this can also be private. So if we want to hide it, proper encapsulation, we want private. But then we need to do this thing, which is once again Unity specific, is attach this serialized field annotation, which means expose this field to us in the editor so we can do things with it. And the reason why we want this exposed is so we can assign the model that we just pulled from Poly as the object we wanted to spawn. And then in our update, it's pretty straightforward. We want to detect if there's a touch. And if there was a touch, then we want to get the touch. And so touches have several phases. They have, or touch count registers several different phases of touches. So that includes, down, hold, and release. And so in our case, we really only want to detect the beginning of a touch. Next touch phase. And then now we want to ask the raycast manager to raycast from where we touched. We want it to assign to this list that we created, and then this last parameter is basically asking is for the raycast manager to know which surfaces you care about. And so this this particular one means I'm looking for, you'll see when once we build and can visualize the planes, these planes are polygons. And so what this is saying is to place the object on the plane within the bounds of the polygon on the plane that was detected. And then all we want to do is get where the hit was. And then, so this instantiate is also a Unity specific thing. It means create this first object. So this is a game object. Create this object at this location and with this rotation. And so pretty simple logic, but we're trying to do a pretty simple behavior just to get a feel of how this library works. And so going back to our scene, we just want to add this component we just created. So plane, place on plane. We just want to add this. Looks like I have a compilation error. It's not allowing me to do the serialized field. I will need a moment to look into that. I apologize for that, but if you make it public, it will.
Isn't that a serialized field?
Serial, perhaps. Thank you. Thank you. Appreciate it. Cool. And now it should show up. And from there, you want to just drag this model. So this one is the one I had with the transform. You can just drag it into this prefab, and now it will spawn this model whenever you tap somewhere on the screen. So that's basically all it takes to make a pretty, just a very foundational, very basic AR application. And then you can go to the build settings. So I have mine configured to run, to build an iOS app. I guess I'll save this as iOS. This will actually give me a build error, I believe. And that's because I did not set up everything I need to in order for an iOS app to be built. And this is because this application needs the camera, and iOS devices require you to tell the user why you want to use their camera. And you also need to have a higher iOS version, just because ARKit has been incrementally improved as well. Yeah, and then this should build. I also have it on the wrong architecture. So there are settings, architecture. Let's see, where is that? Here. So yeah, basically, so this is the console. There's an issue building. That's a place to look. It's also where debug messages go, as well as any errors, crashes, stack traces. And so this is where it slightly differs if you have Android versus iOS now. So if you're on Android, you should be able to just play this from the editor. You can plug in your Android phone, and if you hit play on editor, you'll be able to use your Android phone and also see the editor updated in real time. On iOS, it's a little bit different. What it does is it creates an Xcode project for you that you then have to, which is the only way you can run this on your iOS app. And so this is a successful build. Going to switch over to Xcode. Assuming you've got your phone to talk to your computer to Xcode for any other application, the only difference with Unity, once it generates a project for you, is you have to make sure that it gets signed. So I just sign it personally, and then I am able to deploy it on my phone. And you get a nice little splash screen, and let's see if I can get it to do anything. And you see some planes showing up, a lot of planes, and I just tapped. You can see it made a reindeer. All right, well, maybe I want to go back to my project and make this reindeer a little bit smaller. But yeah, so that is a very basic start, but now you have planes and you can interact with the world just by creating game objects, moving game objects around, and adding scripts to make your interactions as complex as you need them to be. So some basic guidelines for doing AR. So these are all things that we've spent a lot of research time into over the past couple years. Just because this technology was so new and we weren't really sure how people would interact with it and what they would like and what they wouldn't like, and also what would work well for the technology or not. And so what we've basically what we've boiled it down to is AR is something that is probably going to be context sensitive, and so you want someone to be able to use their application in like a dimly lit small apartment like the one I'm in, or you want them to be able to use it outdoors on a big field, and you have to understand that this experience travels with people. You also want to define size. So in the case of what I was doing just now with my reindeer being ginormous, it might actually be what I'm looking for if I'm trying to work with a full-size reindeer. But size is context specific to, like, this application I built may have only been something I wanted to use on my desk, in which case maybe I only wanted little miniature items to be spawned, versus if I were out in a field. And so having the size of your experience decided and communicated to the user prior to them jumping into it is good practice. Something that we also aim for our experiences to do is to encourage the user to move around. So I don't know if you noticed, but I had to sort of move my camera around in order for AR Kit to find planes. And basically, the more that we can encourage our users to move in a panning, sliding motion, the better it is for the toolkits that we have available for us to be accurate with their sensing and their plane detection. It's very important in AR to keep the user safe. I don't know if many of you have played Pokemon Go, but that was an example of AR that maybe wasn't focused on keeping the user safe. It was a very fun, engaging experience, but there was an issue with people just being so engaged that they didn't pay enough attention to where they were going. And similar experiences to this was Google actually launched a walking navigation AR app not too long ago, which they even more recently pulled just because the navigation was so distracting from the actual environment that it just wasn't a safe product to have available to users. And the last one is AR is augmented reality. You are trying to add something to a reality, and a lot of what we subconsciously expect is things like lighting conditions, things like materials, things like saturation, and because what we're adding to our environment is entirely artificial, it's important to try to get that to fit the existing context. And so a lot of things I just mentioned, like lighting, that's something that the game engine will provide, but that's something you want to think about when talking about the content that you're trying to place in the environment as well. The last one is to make a clear transition into AR. So you want to make it very clear when the user is looking at their phone at what is just raw camera feed, and when you're actually overlaying and changing the environment. And so things like this are particularly important when you think about AR experiences like makeup experiences. You want to make it very clear when a person is looking at their own face. and when they're looking at a face that you have changed. And the same thing with, filters and whatnot that we have on a variety of applications these days, a lot of mobile apps these days. And so AR and VR, so I've been talking mostly about AR up until now. What's the main difference? So I like to think about AR and VR less as like two options and more as a spectrum. If you like, what I like to describe VR as if you take opacity and just turn it all the way up to 1. And so that's a toggle that you have complete control over. And the main difference between them is, so this is the walking app that I mentioned, Google shipping. But AR is great for providing context-sensitive information. So that's usually where you are, what you're looking at, and what your motivation for using this app is. Other places where we see this is in industry, where we see AR applications overlaying maybe installation instructions over someone who's putting together something kind of complicated, or like medical use cases where someone is looking at a patient and it's cumbersome or even worse to have just random items to look up around them. Having a heads-up display or even like, an on-person display providing augmented data like this is very useful. VR, on the other hand, I want to call it a little bit more creative. So this would be things like games. If you want to create an immersive experience, VR is exactly that. In enterprise use cases, you can see things like Tiltbrush, where people wanted just a blank slate where they could create things that they wanted to do. When I was at Tesla, I worked with a VR team that visualized cars, which was a much cheaper and faster iteration cycle than actually mocking up a complete car just for a designer to tweak it and say, nah, build it again. And so Unity also allows you to build a VR experience. The one caveat with working in VR is that you usually need, or you do need specific hardware in order to make that happen. Like as far as Unity goes, you basically just need to change a couple toggles and it makes it pretty easy. If you're working with a tethered VR headset, you want to build for PC, Mac, or Linux, whatever you're working on. Usually PC, I would say, at this point. And the other difference is what I mentioned as the origin. An AR app initializes that where your camera starts in the beginning. In VR apps, there is something called a guardian system. And basically, because a VR system is opaque, you don't have a really good placement of where you are in the environment. And so there is a system that shows up when you're about to leave your safe environment. And that's why your origin of your scene is placed where in the middle of that to maximize the amount of interaction and just to guide where you should keep the objects within your game. Oculus Quest requires deployment through APKs, but because it's Android, it's similarly flexible in that you can tether it to your editor and play with test in editor. And Google Cardboard works similarly for that as well. Both Oculus and Google Cardboard have more specific instructions as far as setup of Unity in order to work nicely with it. Oculus recently released this XR plugin framework that Unity has been working with them to make their development cycle easier. And so I haven't personally had much experience with it, but Oculus has quite extensive documentation, and I would, it's in the resources I provide. I would recommend taking a look if you happen to have an Oculus and you would like to work on it. So VR development guidelines are somewhat different from AR guidelines, and this is because AR is focused on adding data to your existing world, whereas VR is based around defining an entirely new world. And in these cases, it's actually possible to go much more wrong than creating a bad AR experience. Like the worst thing you can do with an AR experience is just that it's kind of nonsensical. It's an app that you don't want to use. But in a VR experience, it's much harder to convince a person that's there that they're there. So you want to create something that makes a person feel like they're in a different space. And turns out we expect a lot of our normal rules of physics to come with us. But if you choose to change them, you should make them consistent and make a person believe that they are in an alternate reality where things still make sense, just in a different kind of sense. The second thing is you want to place UI, usually around, you don't want people to contort to be able to do interactions that they would have to do all the time. There are a VR headset you want to keep in mind is already pretty heavy. It's, the last I checked, it was 3-ish pounds to 3-ish pounds, which, you know, is a good 10% on top of your normal head weight. And so you don't want them to contort, look wildly to find their UI and whatnot. This just leads to ergonomic problems that arise pretty soon after. Well, they arise pretty rapidly because the people who use VR, it's also easy to lose your sense of time in it, and people use it beyond the they don't normally take breaks. They don't take breaks as you normally would if you were, for instance, sitting in front of a gaming console. Another thing is, so VR, we mostly use controllers right now. I think Oculus is also doing some hand tracking, which I'm very excited about personally. But right now, all of the interactions are very exaggerated. Like if you want to click on something, you have to jab really hard at it, and it just doesn't feel very natural. And the reason for that is just hand detection is a hard problem. So that's something that not many people are working on, and I'm excited to see where that goes. But we also have controllers that are much more commonplace. And there are a lot of buttons on these controllers, and they can be used in combination. And what I would recommend if, as you're designing these interactions, is pick something that makes sense. You know, if you are trying to shoot a gun, sure, consoles use use your thumb to do it, but because there's a trigger button, then you would probably want to use the trigger button. Things like that. There's also like a button underneath your third finger for most of these controllers, but you don't want to use them in weird combinations just because you need to come up with another combination for an interaction. The grip button I've normally seen for things like, pulling sword hilts, like swords out of like hilts on your back and things like that. So these buttons are pretty contextual, and there's usually like one that feels the most natural. A fourth one I would say is maybe the most important thing, which is to allow users complete control over their actions. VR motion sickness is actually not all that hard to induce. And the reason for that is we have these inner ear bones, which basically when their sensory outputs don't match our vision, historically it's probably because we ate something that was really bad and we should get rid of it. And so when we put a screen on our face and we simulate the same thing, people feel really ill really quickly. And one way to mitigate this is it's kind of like the driver of a car doesn't usually get car sick because they anticipate how the car is going to move. It's the exact same thing for this. So actions, if you just suddenly start scrolling the screen without any user input, very likely to make a person sick. But if you allow a person to control how that screen scrolls, it's a much better experience. Something also that's very handy in VR is to use how we naturally interact with the world, within reason. But if you want to convince a person that they need to, move an object from point A to point B, in VR you actually can do that if you're not moving it that far, and that creates a much more immersive experience if they're working in the real world instead of perhaps old school interactions where you can just like grab and then drop, with one hand. If you're trying to grab and drop a barrel with one hand, that doesn't really make sense. It kind of breaks the immersiveness. It's also kind of something I've seen that I've appreciated in games. Is just subtle things. It's like if you have a barrel that's difficult to move versus like a door that's easy to open. That's one way to convey to the user that they should probably take the door instead of trying to mess with this barrel if they're just trying to get across a boundary that happens to have both. So these are just like neat little game design things that I think VR can take advantage of in a way that gaming consoles up until this point aren't able to. And the last one is VR is kind of difficult to be precise, just because most people, when they're moving from their shoulders, and our shoulders aren't nearly as precise as our fingers, and we're used to the precision of our fingers on mice and keyboards. And so one thing you can do when you're developing a VR experience to make it feel very comfortable is to basically help them stabilize whatever they're pointing at. If it's like aiming, if you're tossing a baseball, help with the aim a little bit. It just makes the overall VR experience much better. These are just kind of my top ones. There are actually far more, especially for VR. In addition to just game design aspects, there are also a lot of computational limits. And these resources, this cardboard one, which specifies for mobile VR, as well as the one for Oculus, they both go into more detail as far as what you should watch out for if you are compute limited in your VR and AR development. And with that, I will open up for questions.
Awesome. Yeah. Are there any questions for Joyce, AR related or non-AR related? Please either type them in the chat or you can unmute yourself.
I just have a comment. I think you're like crazy talented when it comes to UI. Like a lot of this stuff I, just take so for granted and then never would have thought about, like especially the shoulder thing.
Yeah, I mean, it was also it was kind of fun because when I first started working on this was not defined at all, and so a lot of us early adopters definitely just had like ergonomics issues working on this. 8 hours a day was our jobs, and being like, my neck really hurts at the end of the day, or my shoulder really hurts at the end of the day. I wonder what's going wrong.
Yeah, wow, that's very different than regular app development for sure.
Two chats.
Mm-hmm. What would be harder to work on, AR or VR? Well, it kind of depends on what you're building. I would say if you had the headset for it, working on VR is a bit easier, just because you control your environment. You define everything that exists in your world. And in that sense, it makes it easier. AR, you have to make fewer decisions about what you're building, but you also have to accommodate a lot more factors that you don't have much control over. But yeah, the nice thing about working on AR is that most people's phones are AR capable these days. And so you don't have to get anything dedicated if you just want to get off the ground with it.
Hey, I have a question. Can y'all hear me?
Yep.
Yes.
So for those of us who want to explore a career path in AR and VR, how much should we brush up on? What should we know about computer vision and AR and linear algebra fundamentals? How in depth does our knowledge have to be? Or are there already a bunch of are there already a bunch of tools that kind of abstract away those difficult problems and you mostly just focus on architecting your app? Or is it just, or do you have to really be really intimately familiar with your CV and linear algebra fundamentals?
I would say it depends what part of AR you want to work on. Like if you want to work on the AR core library or the AR kit library, then yes, I would say machine learning is critical for roles like that. If you are looking for a role that just utilizes APIs, usually their integration into a game does need some amount of linear algebra, but it's things like Unity, things like this, because it's abstracted away in a game engine. It's possible to use libraries without a very intimate knowledge of the linear algebra itself. And so it's kind of just where on the library to application spectrum you want to fall.
Thank you.
There are 2 more questions in the chat.
Is the cross-platform the primary reason for Unity? C# is a pretty high-level programming language. Yes, C# is basically Microsoft's version of Java, and Unity uses either C# or JavaScript, actually, but I personally prefer C# because I think compiled languages are the way to go. The cross-platform reason for Unity is because they wanted to make it easier for developers to ship on all devices, and that was I mean, that is their business strategy. It's pretty great that they offer their platform for free to small developers and independent developers, but also things it's like Tiltbrush was built on Unity, and so they also are attempting to do like business level deployments and licensing. So that is why Unity is cross-platform, is because that's they're aiming to make it easier for developers to reach larger audiences without additional work. Which do you feel is a better movement method for experience in VR, teleportation or locomotion? Locomotion is challenging. Well, actually, I'm going to clarify. It depends on what kind of locomotion you mean. If you mean locomotion by walking, if what you're interacting with is in a small enough space that most people can walk to it within the span of their living room, I think that's the best way to go. That's the best way to keep the experience as immersive as possible. But if you're trying to get someone to an object that's 50 feet away, teleportation is probably the easiest way to do it. And the reason for this is because people blink in and out of spaces, so you don't have this acceleration problem that I mentioned earlier, which is what makes people sick. There are certain experiences that have done it well. So one such thing to do locomotion is that they've done kind of like a tunnel vision effect, where you can basically bring in the vision, bring in the viewport of the user, and basically like shift them very rapidly to where they're going and then zoom it out. And so people feel less motion sickness. We're not actually sure why they feel less motion sickness because of this, but maybe it's something like watching something on a TV. If you watch, a fast moving scene on a TV, you don't feel sick because you don't feel like your entire body is moving with it.
I actually have a question. In college, which CS class do you think is most applicable in your experience in industry? Which CS class do you feel like is the most important one that you've taken?
Good question. I want to say the class that I use most, and I'm not sure how classes map to yours, but to your school. But in my school, it was a sophomore level class, and it was data structures, algorithms, time complexity, and whatnot. That is what I use day to day, and it's pretty applicable even to either the computer graphics stuff that I focus on now and the machine learning stuff I focus on as well. Like it applies to everything I do pretty much. So I would say that's definitely the most useful. As far as the field that I went down specifically, I mean, I learned about machine learning on the job. There are courses I regret not taking, but my school had a senior or master student level class that was focused on computer graphics. and it taught everything like how to use OpenGL to I think we all implemented like a transforms library just so we knew how engines like this work. And to be honest, like these engines are written by people too. Once in a while, you come across a weird bug that like you can it's not your code. Like you can figure it out that deep, and sometimes you even just dive into engine code and be like, yeah, it's definitely in there, and then submit a pull request to have it fixed.
Okay. Are there any other questions? If not, we'll move on.
I got a question. Let me make sure I'm not echoing.
Go ahead.
So it's kind of my impression that, like you were saying, VR kind of blew up and was the hot thing for a while. And then it died down a lot. Do you feel like the larger companies like Google and Apple like shied away from this because there were certain significant hurdles of VR, and they're expecting AR technology to mature more so that you can have some kind of AR VR hybrid, like with more advanced goggles or optics, so that people don't feel like disconnected from their surroundings. And so it'll take a couple more years, or maybe even more, for that technology to incubate before this blows up again.
Yeah, so I think it's interesting because it did die down a couple years ago, I think. And I'm personally hopeful that we're actually already seeing the beginning of the re-uptick. And the reason for this is when VR first started, well, it first started becoming big in the 90s, but the second uptick, I think the reason why it didn't take off the way we expected it to is because the hardware was just a little bit too expensive, and it was just not quite good enough. I mean, to put it into context, like a VR headset was somewhere like $600, and a PC to run it was something like $3,000. And you can look at that, or you can look at your $400 gaming console, and then the market decides the rest, if you will. And I think it's very exciting seeing like products like the Quest come out, just because that is a very competitive price with a gaming console. And I like Facebook has done some pretty interesting technology as far as like machine learning, like on-device machine learning, to smooth out tracking. So it's like the hardware is only maybe incrementally better because we're not using it to brute force a better frame rate and better rendering. We're using that slight hardware improvement to improve our machine learning techniques to smooth the rendering and improve the experience much more than if we had just applied that to the graphics output.
Cool. I just want to say thank you. I kind of went back to school, and part of it was because I got really interested in AR and VR. So it's cool to hear a talk from you.
Yeah, thanks for attending.
Okay. Any other questions? Going on. Going twice. Okay. If there are no other questions, we'll go on to our next slide. This is actually ACM slide, so Melissa will go over it. She's still there?
Hey, sorry guys, I'm half in a class, half in here. This is the ACM's contacts. Instagram is up top, ACM_SFSU. Our Gmail, if you want to get into contact with us. Our Slack, which has about 3,000 people on it, and you can ask any questions. Contact professors. It's a great resource. If you're not already on it, you should really be on it. And then our LinkedIn, we are connected with other ACM members around the world and with alumni. So it's a great place to connect.
Awesome. Yeah. If you're a CS major or engineering or part of any college, really, so this is a great environment to come and meet other people, meet professors. There's a lot of people on the Slack. So if you have questions about classes to take or enrollment dates or anything, you can always just send a ping in there, and then someone out of the 3,000 will answer you. Okay, so this is SF Hacks slide, and I just wanted to let you guys know that we will have our next workshop the week we come back after winter break on January 29th, and it will be an AI workshop. So definitely stay tuned for that. You'll see flyers coming out during winter break. You can also keep in touch through our social medias. This link, all the links will be in the chat, and this link will take you to our Instagram, Twitter, LinkedIn, all of the other social medias, and then you can totally scan this QR code to be a part of our Discord server. This is where you hear a lot of our announcements. It's our main form of communication. So please, if you can, join that to keep being informed of our events. Also, we have a feedback form for this workshop. For the people that are still here, if you could fill out this feedback form, it's really helpful for us to provide good quality workshops for the student body. We really cherish all of your guys' information and constructive criticism. So please, if you can fill it out, that'd be great. And also, SF Hacks is holding their annual hackathon in March, as I mentioned prior. And we have a hackathon planning form where you can go and suggest some games that you'd like to see, or some workshops, or some prizes that you would like to see as well. So everything is in the chat, and I hope to see all of you at our next workshop and at our hackathon. I want to thank Joyce, and if you guys want to thank Joyce as well, she was a great presenter, very informative, and honestly just such a great workshop. I'm really happy that we got her here. And if there are no other questions, feel free to drop off, and I hope all of you have a great break and good luck on finals, because I know we're all stressing about those. Yes, of course, no worries. Okay, bye guys. Joyce,